Hello, I'm Rajashekar and my teammate Sharo Prasad. We have built agriscout AI. It's an autonomous agentic field scout. It has a combination of drone which confirms issues over various zones of the huge acres of land, and then there's a ground robo which performs various tasks for the action. So the problem that we are trying to solve is it's for the farmers who have huge acres of land, and we want a drone and a robot to do some autonomous actions to help farmers find out any issues the crops may face in a very quicker time, and with the help of the latest technology, agentic AI. And yeah, let's see how it all works. So farmers are given a mobile app like this, and here they can clearly get all the alerts about the various zones in their farm, and if there are any issues it will show up here. And we have a data pipeline which sends regular alerts based on the satellite imagery data on any anomalies or issues that they need to check up. Now let's see, we got an alert, and now the farmer can either choose one of these zones or he can just choose to act on this alert. Let's choose to act on this alert, review and dispatch. And now here the drone will autonomously get dispatched within 30 seconds. Either the farmer can hold off or he can choose to send now. Let's say I choose to send now. And once I choose to send now, if you see here, this is the field drone, and it is using Gemini robotics ER 1.6 model for VLA actions, and also Gemma VLM model. Now it is making tool calls, and now it is moving towards B3, that is the stress zone that we have identified. Now you can see the VLA action tokens being generated, and it is moving towards that particular B3 zone. Once it has done the coverage of like one wide scan, next it needs to do a close-up scan. Yeah, so once it does the close-up scan, let's see, tool callings is done, and still it needs to do a close-up scan. Now the close-up scan is done. Now it needs to send off this particular task to the next task to the robo for a closer inspection, and the robo needs to perform this particular four tasks. One is inspect affected leaves, compare with healthy leaves, probe soil moisture, and place a GPS trap marker. Now similarly, this drone also robo can also autonomously take off, or I can approve and dispatch. Let's wait for another 8 seconds so that it will autonomously get dispatched, and let's watch it. So this is our field robo, and you can see it is moving through B3 zone, and now it will start performing the actions. Now you can see the action tokens which are being generated by the Gemini robotics ER 1.6 model, along with Gemma 4 open source model. And as per the action tokens, it needs to perform the next task of inspecting affected leaf. Yeah, let's wait for the tool call to happen. Yes, now the tool call has started, inspect leaf with wrist, and now that is the action that is being performed by the robo. And if you see, so this part is done. The second tool call is to compare with healthy leaf. That is also done. Now that next action is to perform probe soil moisture, which is also being done, and the final step is to place the GPS marker. And once the placing the GPS marker is done, it hands off to the next task of doing the report. So this is done, and now finally the report is here. This is the entire report for the analysis, what all it has done, and yeah, this is the evidence that is collected, and finally recommended action. And now we can this is the solution we made, agentic AI solution with an autonomous drone and autonomous robo, and these are the two simulation software provided by Davis Autonomy Club during this hackathon, and we built on top of it. We used Google ADK for the entire orchestration of all the agents, and then Gemini 2.5 Pro for the orchestrating brain, and we used for the VLM we used Gemma 4 installed with Olama, and for embodied reasoning we used Gemini Robotics ER 1.6. And it was great working on this technology, and we developed the new UI and the actions of the robo for the generating action tokens. Thank you. This is from hackdavis2026.